Okay, lesson 4, and the good news is we're finally going to make some gameplay, graphics and sound effects. The bad news is I'm not going to finish this game for you. I'm going to leave it in a state where you have to finish it off, but hopefully by then you should know how to do that. So I'm going to load up Visual Studio and create a new project. Just before we get to the graphics and gameplay, I'm going to introduce you to the idea of a game loop. So I'm going to start a new project. It's still going to be a console for now, but don't worry about that. We're going to switch away from that very shortly. So this is an example of game loop. So I'm going to call the solution game loop as well. So we'll start up with all of the usual stuff you get in a console application. And what my program is going to do is it's going to keep a couple of variables, Boolean variables, for whether you've exited the game. I'm going to keep the player's position in mind. And we're going to use an icon for the player character. If you're familiar with roguelike games, the player is often represented by an @ symbol, so I'm planning to use that. So that's just 3 pieces of data the game's going to store. But throughout the game actually before the game starts, we're going to have to initialize it. So the initialization phase is where we take those variables and give them initial values. So exit game means we're trying to exit, and just as the game's starting, obviously that's not true, so that's false. And the player is going to start at position, let's start in position 0. It could be the middle of the screen, but I'm going to go with 0 for now. Also, before the game starts, you usually preload some of the content that's used in the game, graphics, etc. You don't really have any of that kind of stuff, but we'll pretend we're doing that right now by giving the player a character to represent them. Then you begin what's called the main game loop. And that could easily be represented as a do loop, containing a couple of phases. First, we update the game world. That's stuff like artificial intelligence, physics, but primarily the player's input, which in this case is from the keyboard. So we're going to have a character called which key we pressed, for obvious reasons. We will read a key from the keyboard and get the character that was pressed from that. If the key that was pressed happens to be A, we're going to use the WASD movement scheme. It's common in PC games. So if you press A, the player's position goes down by 1. I've not used curly brackets in this case because it's such a simple expression, and also to make it easier to cut and paste. So that's what we're going to do. If you press the D key, the player's position will instead increase. And we do all that. You'll notice there's a red line at the bottom there of the closing curly bracket, because it doesn't know what condition will keep the loop going. So I'm going to say keep going while exit game is not true, it's false. Or a shortcut to that, by the way, is exclamation mark. That means not true, exit game. But that's just the update phase, and we don't see anything yet. So we can press A and D and it will respond in real time because it's in a loop by changing the player's position. But that doesn't affect anything in the game world. We need to see that happening. In fact, no, it's not in real time, sorry. It's not in real time because read key waits for you to press a key. Let's make it real time by checking if the console has a key available for us. And we'll only run all that code if it does. Now it's real time. We still need to draw the game world though, so that's the next phase of the game loop. Draw the game world. And it's typical to clear the screen first, because otherwise you'll have bits and pieces floating about from the last frame, which you don't want. And we're going to loop through. There's other ways to do this, but so as to stick with techniques that you're currently aware of, we're going to use the for loop. And the for loop is going to be controlled by this variable called spaces, and that will keep track of how many spaces we've drawn on the screen, because it's going to count from 0 up to whatever the player's position is, one by one. So whatever the player's position is, it's going to do this. It's going to write just a space character to space it out. So if your position is, say, 10, it's going to draw 10 spaces. If your position is 20, it'll draw 20 spaces. And then after it's done those spaces, we then write the player's icon to the screen. So the position controls how many spaces you've got. As that changes, sorry, missing semicolon. As that changes, the spaces change in front of the icon, and therefore the player's position changes on the screen. Let me show you that working. Oh, or not. What's the error? Oh, I missed the curly bracket. Curly brackets are the number 2 cause of errors after typos, in my opinion. There it is, a little @ symbol. I press D, he moves right. Press A, he moves left. It does stop at the edge of the screen. My position is negative, but the way the code's structured, it won't let me go past the edge of the screen. And I need to press the key a few times to bring it back. But he's moving, and more importantly, he's moving in real time. We have a real-time game loop. We're not taking very good care of the frames per second, the frame rate, but it's working. And that's the general structure of every real-time and most turn-based games as well. There's an initialization phase, and then a content phase, and then we begin the loop, which contains an update and a draw. The update's usually broken down into subsections as well, but we'll get to that. And because every game is that same way, people who developed the MonoGame thought, why not abstract this out? Why not make it available for everybody? So if we have MonoGame installed, you can create a new project based on C#. Where's MonoGame went? It's usually got a little. Oh, there it's there. MonoGame Windows project. As you can see, you can make MonoGame projects for Windows with OpenGL instead of DirectX. You can make it for Windows 10. You can make an Android, Ouya, or Linux project. There's other ones available as well, but you need licenses for the PS4 or Xbox. So we are going to make Pong game. Pong being one of the first video games ever. I'll mean Boing. It's not Pong for legal reasons. And it's a MonoGame Windows project. Click OK. And you get sort of familiar setup. It's got your code window over here, which is currently empty, and your solution over here. But look, the main difference here, we've got 2 CS files. And the one you're used to seeing, program.cs, is still there, but it looks a bit different. You've got this if command, which ends down here. So that it runs this code for Windows and Linux. It's so that you can make your game compile for different platforms. You can put different code for Android or iOS or whatever. And there's our main method, as usual. There's a whole bunch of comments, of course, so let's take them out so it doesn't confuse things. And don't worry about what that STA thread means, we'll maybe look at that later. The main is what we're interested in. What it does is it's got another using. Your usings are not always at the top here. Sometimes you can use things during the code. And var is short for variable. It just means it's a variable where we're not going to tell you in advance what kind it is. So we've got this variable of some kind called game, and that's going to be a new game1 object. We don't know what game1 object is yet, but when we create it, we then run it. So all our program does now is it runs a game object. Sorry, a game1 object, beg your pardon, game1. So where is game1? Well, that's the other piece of code. And there's no main in here because we've already ran the main. The main brought us in here. And game1 is based on, that's what the semicolon means, is based on a game object, a game class, which is part of MonoGame. And that controls how the game loop is set up and runs. It splits all that up for you. And it makes a whole bunch of stuff in here. Again, I'm going to take out some unnecessary stuff and minimize things so that you can see a bit more of it. especially the to-do comments. Please don't forget to take out comments that are reminders to do stuff, especially after you've actually done it. It's one of my pet peeves. I'm also going to take out this line here, which is just a response to an Xbox gamepad, and you can press the back button to quit. I'm not going to use an Xbox gamepad, so I can take that out. So hopefully some of this should look a bit familiar. We've got an initialize phase. We've got a load content phase. There's also an unload, which runs at the end. We're probably not going to use that for quite some time, but it's there. Here's the update where you would do your AI, physics and inputs. And here's the draw. You may have noticed I skipped over this one here. This is the constructor. The constructor is a method that has the same name as your class. So it runs first before anything else in your class. It's used to construct or create your class. And it only does two things. It sets up the graphics. It creates a new graphics device manager to control or manage the graphics in your system. And it sets up the directory where it's going to load the content from. There's this thing called content, which is a content manager. In fact, if I hover over it, content manager, which you can use to load in graphics and sounds, etc. We also have access, there's our graphics device manager. We also have access to a thing called a sprite batch. Sprite batch is used to collect a batch of sprites, which are going to get drawn to the screen. And when you close that batch down, they all get flushed out onto the screen to draw one frame. Okay, if we run it right now, you will see just a blue screen, but at least it does run. I got rid of that horrible black DOS box window. If you run it right now actually and try and move the mouse onto it, you'll see the mouse disappears. So there's a boolean we can use called isMouseVisible. If you want the mouse to be visible in your game, here it is, isMouseVisible equals true. That's that. So it's responding to our code. It's currently got a frame rate as well, which is it's targeting 60 frames per second. It'll try to get 60 frames per second. If we want it to be smoother, we can change the target elapsed time. So a frame rate is 60 frames per second, which is 0.16 milliseconds per frame. But we can get our own time span to determine how many frame rates we want. So we convert from seconds 1/100th of a second. So if we want 100 frames per second, that is the idea, but it won't work. And it won't work because 1 divided by 100 is 0.01. But from seconds, well, these numbers might be treated as integers. So we put an F for floating point. That will differentiate between an integer and a floating point. And it also stops things being treated as double precision. In fact, I think that's what it is. Yes, from seconds, look, it says double value. It's expecting a double precision, but we'll make it a float. Anyway, that's just a long way of saying that the target elapsed time is a time span which determines the frame rate. And lastly, we can still change the title, but now we do it by saying window.title instead of console.title. So it's not a console thing anymore. Okay, let's click run. You won't really see the frame rate in action because there's nothing happening, but there's the title and there's the mouse being visible. That, by the way, is the default size of MonoGame or XNA window. We can set our size as well using the graphics device manager. And one of the attributes it has is a preferred back buffer width. I'm going to set that to 1024. And a preferred back buffer height, which I'm going to set to 768. Your PC or laptop very likely can easily be capable of much higher resolutions, but that is what I would recommend if you want to be able to run this on almost any PC. You may, when you do that, have to apply those changes. That is a command, a method, so it comes with curly brackets. And finally, when you run it, the window spawns and it's going a little bit off screen. So we can set the window's position it's a point variable which has an x and y coordinate 0, 0. So 0 pixels along, 0 pixels down, and that's the point where our window is going to appear. There we go. Still a bit of bookkeeping involved, but we're ready to start. Let's have a look at the update and draw. Update is pretty much empty except for this base update. What that does is it just calls up the update from the base game, which is MonoGame. You should really leave that in, but make sure it's the last thing the update does. Same for draw. But the other thing in draw is graphicsDevice.clear. It clears the screen in a particular colour, and you can choose any colour you like. Colour.red, colour.blue, colour.goldenrod, whatever you like. Or you can also make your own colour. Notice that that colour word is, first of all, it's an American spelling, because obviously it's an American product. But you can also define your own colours. So I went online to Crayola and found some colours from there. There's one called Alien Armpit. And it's got the precise colour values of 132 out of 255 red, 222 green, and 2 blue. Colours are made up of, in fact, if I open that bracket again, colours are made up of RGB values, red, green and blue. Mix them together, you can get any colour you want. So now instead of passing a specific colour in, we can pass in the variable that we just defined. There we go. Very retro looking Pong screen. But where are the graphics? Let's make some. The graphic is usually stored as a texture 2D, a two-dimensional texture which we're going to draw. So let's declare a background image object based on that. Now we need to load a texture in from disk. So we don't actually have one. If you open up the content folder over here, there should be a file called content.mgcb, MonoGame Content Builder. And double click that, it should open the content pipeline. This seems to have previous set of content in it. Let me open the one for Boing project. Yeah, it's empty. So the MonoGame Content Builder is just a folder with content, and it can build it into a format that the MonoGame executable will understand. So I'm going to add a bunch of existing items. Oh, sorry, I went through that rather quickly. The edit menu has an add option. You can add existing items or a whole folder from disk, or you can add new items and it will create folders or sprite fonts or what have you. So existing items on disk, I'm going to look around at where I made a version of this earlier. Two different sound effects. You can hold down the control key to select multiple things. Two different sound effects for bouncing, one for scoring a point, a background image, a ball image, and a bat. So it's usually a good idea to have an idea in your mind before you start what graphics you'll need. Obviously it will change, but it's good to have a starting point. And there we go. Let's close that down. Do you want to save the project? It just means the content builder project, not the whole thing. And now it has access to these things through the content manager. So in the load content method, and remember this runs before the game starts, in the content load content we are going to say background image equals, we're going to assign a value to it from the content manager using the load method. And the load method has a generic, which is like these angle brackets. The generic tells it what kind of thing to load. Load a text or 2D. And then you have the regular parameters, which tell it the name of the file to load. Pong background. You'll notice it's not pongbackground.jpg. When you build it, the dot part disappears, and you're just left with an asset name. Okay. So now we have a texture, we need to draw it. Here's the draw method down there. Before we can draw anything, that sprite batch needs to know when to begin collecting textures and when to flush them to the screen. That's the end of the batch. And in between that, that's when you draw things. That's sprite batch.draw. So as you can see, there's 8 ways to draw things. And we will look at a few of them shortly. But what I'm going to start with is draw the background image using a vector. So a vector is a collection of x and y coordinates. In fact, I'll make a new vector too. collection of x and y coordinates, which in our case happens to be 0, 0, in the top left corner of our game. And finally, we need a colour. I'm going to stick with white because that colour actually represents a tint. So if you tint it with white, you're going to end up with the same image you started with. You can give it a red tint or a blue tint or whatever to change the colour of the image. It doesn't actually mean it will definitely be red or blue. But anyway, if you run that, there's our texture. That's the Pong playing field, but it's kind of too small. Let's scale it up. So instead of just telling it where to draw, let's use the rectangle version. And a rectangle has, or can have, 4 different input values. We're still going to have 0, 0 to start with, that's the top left corner, but then we're also going to have 102, 4, 7, 6, 8, which is the width and height of the image. And it will scale it up for you. But ooh, it looks kinda blurry. That's because of the way the graphics device manager is handling scaling. So we can change that by going back to the begin method and telling it to use a sampler state, which is sampler state dot clamp. Oh, sorry, point clamp. Don't worry too much about exactly what that does. It's just, it means draw things a little differently. And there's different ways to do it, obviously, as you saw there. So now it's not anti-aliasing it, you don't get that blurry effect. It's pixelated deliberately. So there's our background image. What about a ball? Let's do that. Texture 2D ball image. And then we've already loaded the image into the content pipeline previously. Let's start by drawing the ball in the top left corner. So again, that has to go inside the sprite batch begin and end. So draw the ball image in a vector coordinate 0, 0 with colour dot white. Now if you run that, it will crash. You may have already figured out why. There's our debug window. Argument null exception, which lets me know that something in that line is null when it shouldn't be. The value cannot be null. Which value? Well, this one. Ball image is null. I forgot to load in the graphic, just to show you what it looks like when you make that mistake. Honest gov. So ball image is going to be loaded same way as background. Load it as a texture. And I think I did just call it ball. No, it was Pong ball, wasn't it? Caps don't actually matter here, by the way. Inside the quotes, that's the only place it doesn't matter. But there we go. Our sort of tie-dyed hippie ball. Because there, how do we make the ball move? Well, at the moment it's drawn in a literal hard-coded coordinate of 0, 0. The answer is to turn that into variables. Now we could put in x and y integers and use them as our coordinates. Okay, and then during the update we could say x goes up and y goes up. The ball will start moving diagonally. But it's so common to have a set of x and y together that MonoGame and X and A provide this thing called a vector 2 to handle it. So let's give it a ball position vector 2. And then when you draw it, we no longer need a new vector, we just use ball position straight away. And instead of saying x++, we can say ball position.x++. We've now got our own variable that has a dot in it. We've been using the dot for loads of stuff. That's, I think, the first one of our own creation. That's an x and a y that we have declared by using vector 2. Doesn't seem like a big saving, but vector 2s are used all over the place. It's good to get used to them. Okay, what's left? Oh, let's make it spawn somewhere different than the top left corner. So at the end of the initialize, we'll have ball position become a new vector 2. In fact, no, I'll not do it that way. We'll do the .x and y separately because it gets a bit long in the tooth. We're going to get the graphics device access the viewport and get the width of the viewport, which should be 1024. Cut that in two, so it's halfway across the screen, but we need to bring it back a little bit. So we subtract half of the width divided by 2. So that means the middle of the ball. In other words, the middle of the ball is in the middle of the screen. Otherwise, it's just very slightly off. So we do the same with the y coordinate, except obviously instead of width, it's height. Instead of x, it's y. And instead of width, it's height. It should spawn now in the middle of our game window. Okay, I think I'll leave it there for now, and I'll come back shortly to do the bat.